Today we're going to be taking a closer look at the periodic table and the families that you find there and the characteristics that break them down into those families. I want you to pause this in just a moment, as you are going to need to make sure that you have one of these papers. Yours is blank. It also has a blank periodic table on the back, and you are welcome to use that blank periodic table on the back or to outline the periodic table that you already have now. We're going to be filling it out as we go along. And I have picked my colors and I've colored them in there. I've got them sitting over here to the side. And when we start to fill it out, we're going to be using element symbols here. We're going to be talking about, is it a solid, a liquid, or a gas? So those phases or states of matter. We're going to talk about how many valence electrons we find. We just did that with our electron dot diagrams, and whether it's a metal, non-metal, metalloid. And then we're going to talk about if it's reactive or not. So you're going to see those things listed on each family on this handout. So hopefully you've taken a moment and grabbed those 10 colors. Make sure you have the paper. Now your colors can be the ones that you see here. We're going to leave hydrogen white on our table just because it was easier for me to find 10 colors than 11 colors, so you can do that as well. That is entirely up to you. You just want to make sure that there's enough of a difference between the colors that they really stand out. We are also going to be doing some labeling on the top, so you're going to want a pencil or a pen to do that. So if you need to do so, please make sure that you pause now and get those. The first element that we're going to talk about is hydrogen. And hydrogen belongs to a family all of its own. It is a diatomic molecule, which means that it cannot be by itself. I cannot just have one atom of hydrogen. It needs to be with a buddy, and its buddy can be itself, and it oftentimes is. It can also be paired up with other elements. It's a really strongly reactive gas, and it was involved in the explosion that you see in that picture there, which is the Hindenburg, which is something that's called an airship, and we think of them now as blimps, only they don't use hydrogen anymore because of what you see occurring here. It does have a promising future as an alternative fuel source for automobiles, so that is something that people are studying at this time. And like I said, I'm just going to leave hydrogen white on mine. The second group or family that we're going to talk about are the alkali earth metals. And what's nice here, you can see we've drawn these are those dot diagrams, and they all only have one valence electron there in their outer shell. And hydrogen is not a member, but we do place hydrogen typically above at the top of this group, even though it does not have traits in common. That's just typically where it's placed because of its atomic number and its atomic mass. So these, as I said, have one electron in the outer shell. They are soft and silvery, and in fact they are so soft that you can cut them with a knife. They are also, which is similar to hydrogen, only found as compounds in nature, and they are also extremely reactive, especially with water. They do conduct electricity, and we do have many uses for them. Sodium and potassium can actually be combined with chlorine and form compounds that we use for salt. Our typical table salt is sodium chloride, and the potassium chloride can also be used for that. Potassium is also combined with several other compounds and used for things like fireworks, so a great deal of difference between the uses for them in different compounds. Sodium, in fact, even though that they are all solids at room temperature, all of these alkali metals, sodium is, if you were to place it in your hand and it reached your body temperature, would turn into a liquid. So it is a very low melting point. So I have chosen to color the new one. Like I said, you could outline the periodic table you already have colored for the metals, nonmetals, and metalloids. I have left hydrogen white, as you can see, and then I have colored in my alkali earth metals and alkali metals, and I have made them red, and I will eventually also put a chart on here to explain what each of those is as well. I'm also going to put up top the number 1 to signify that there's one valence electron in that group or family. And on the front, and you can pause to help yourself out here, we have lithium, cesium, sodium, francium, potassium, and rubidium. As we said, they're all solids at room temperature, even though several of them have very low melting points. As I pointed out, sodium will melt in your hand. That one valence electron, they are metals, hence their name, alkali metals, and they are extremely reactive. So with the reactivity extremely active, must be be found as diatomic molecules, not by themselves. I can't have a single atom. So I need to have at least 2 of them together or have them combined with something else. Our next group or family are the alkaline earth metals, and these have 2 electrons in their outer shell. They are harder and denser and melt at higher temperatures than the alkali metals, but they're also very reactive. So they are similar to the alkali metals, just not quite as reactive. So remember, as we go from left to right, we lose some reactivity across the periodic table. We see that trend. These metals are also never found uncombined in nature. They usually are combined with something for either a compound or with themselves, again, as a buddy. And they are also some really important minerals and nutrients that we need, such as magnesium and calcium. So, as I showed at the beginning, I colored mine. I chose blue. We said that these have 2 valence electrons, and I've actually started my key up here to help keep track of that as well. On our other side, we're going to list out what those are. And we have Be for beryllium, Mg for magnesium, Ca for calcium, Sr for strontium, Ba for barium, and Ra for radium. These are solids, and they have 2 valence electrons. We are still in our metals, and they are reactive. They are also highly reactive, but not as much as group 1 or family 1. Our transition metals, as you can see, take up a bulk of our periodic table. So we're not going to list those all out. We have some numbers already written down there for you. And they also vary in their number of valence electrons between 1 and 2, depending on odds and even numbers of atomic mass. And they are also metals. And they are able to put up to 32 electrons in their second to last shell. They can bond with many elements in a variety of shapes. They can be used in jewelry. They are good conductors of heat and electricity. They can be soft, they can be extremely hard, they are shiny, and one of those transition metals, mercury, is actually found as a liquid at room temperature. So the rest of them have very high melting points, except for mercury sneaks in there, and it is a liquid at room temperature. They are very malleable. Like I said, they are highly used. There are a lot of the ones that we think of when we think of metals. We've got copper and iron and nickel and gold and silver. So metals that we are very familiar with. So our transition metals right here in the middle of that table. Ours hops down here and it has these little cutouts. Those are going to be our rare earth metals. And so we're going to talk about those last. So I'm going to put those down there. Now the number of valence electrons up here is 1 or 2. Just depending, you have to work out those diagrams to see what they are. So when I flip back over here, we are talking about solids again, except for the exception of mercury. And it is a liquid at room temperature. 1 or 2 valence electrons. These are metal. These are much less reactive. One example might be that iron reacts with air forming rust, but that can sometimes take years to react completely. So these reactions are much more slow. And we also saw that with copper in our lab. When we added the acid, it took over an hour for it to start to react to the point where it started turning the acid that blue color. Whereas, we saw magnesium and it reacted right away, very quick. The next family that we have there is the boron family. We can see where it's located there. We have 3 electrons in the outer shell. This is group 13, and there's 3 electrons in the outer shell. They're all metals, except boron is a metalloid. And we've colored the boron family purple for me, so you can see it there. And remember, we talked about when we have the 3 letters, these are elements that they can predict are there, but they have not made those yet in the lab. So technically in this group, we do have boron, aluminum, gallium, indium, thallium, and yttrium, which is our 3-letter one. The elements in this family are indeed solids. They have 3 of those valence electrons. They are all metals except boron, which is a metalloid. And as we said, the reactivity is really growing less. Carbon is our next family or group, and that would be group 14 on our periodic table if you're counting over by columns. There are 4 electrons in the outer shell. This column or family also contains metals, metalloids, and the one nonmetal, which is carbon to start it out with. And carbon is just an extremely important element to chemistry and to life as we know it, from fuels to diamonds to us. We are carbon-based life forms. So that is why it gets its own. As you can see, carbon's been colored orange, has 4 valence electrons up there. When we flip over to our other side in that family there, we have carbon, which is denoted by a C. We have silicon, which we know is a metalloid. So carbon is a nonmetal. We have silicon, which is a metalloid. We have germanium, tin, lead, which we know is common metals, and flerovium. These are indeed solids. They have 4 valence electrons. We're going to have carbon is our nonmetal, silicon is our metalloid, as well as germanium, and then we have tin, lead, and flerovium, and these are all metals in this group, and we definitely have low reactivity going on over. The next family after carbon is nitrogen. They are in group 15. They've got 5 electrons in that outer shell, and nitrogen itself is a gas, and it's one of those mixed groups. And I think it's important to point out that all those mixed groups where the family is not just metals or just nonmetals or just metalloids, those mixed groups all gain, lose, or share the same number of electrons within their family. So that still holds true. And they also, many of them have played an important role in the topics that we've discussed earlier here. So for example, nitrogen, we talked about the nitrogen cycle and the fact that nitrogen makes up 78% of our atmosphere, that it's a gas that we're unable to use, and then it has to go through that cycle in order for us to be able to use it. It has to undergo nitrogen fixation. So the nitrogen family we are going to color. We're going to color nitrogen gray and note that it has 5 valence electrons. It also has one of those elements with the 3 letters that mean that we can predict that it's there, but we have not been able to actually manufacture that. Now, while nitrogen is a gas, and we pointed out that it makes up the majority of our atmosphere, phosphorus is the other nonmetal in this group, and it is in fact a solid. It is highly reactive, though, and I'm going to slide it up so you can see that, hopefully. The reactivity in this group is low unless, as long as nitrogen is a diatomic molecule. And remember, that just means it's a nitrogen and a nitrogen combined together so they can share those electrons and keep each other from reacting. And the phosphorus is reactive unless it's in a compound. So we're not talking about a diatomic molecule. They were actually talking about a compound with another element. Our next family is the oxygen family, or chalcogens, coming from the Greek word chalkos, which refers to ore, and it's because they can all be found in ore, and particularly copper ore. This is group 16, and there are 6 electrons in the outer shell. This family does contain metals, metalloids, and nonmetals, and it is reactive. Oxygen is obviously necessary for respiration, and many things that stink contain sulfur, such as rotten eggs, garlic, skunks, etc. The oxygen family is found right here. This family 16. It has 6 valence electrons, which is why I remember how we're numbering them. And we have oxygen, which is indeed a gas, and it's usually found as a diatomic molecule, so we have that O2. We also have sulfur, which is a nonmetal, and selenium, which is a nonmetal. We then have